Here is another pricing model, and this one is about a clothing retail store, Sullivan's upscale men's clothing. Now, in this problem, we have one product, and then the sale of that product generates sale of other products, subsidiary products, accessories, if you will. So if you buy, for example, a smartphone, then you may want to buy a car charger and maybe a cover and so on. So how do you price the main product, and how do you price the subsidiary or the accessories? So that's the objective here. Okay, so now this opens up a possibility, and sometimes they do this. They price the primary product really low, even sometimes below cost, such that when the primary product generates demand for the accessories, they make their money from the accessories. So how do you consider all of those different complexities and come up with pricing? So that's what we're going to do in this example. So let's go to Excel file and look at all these numbers that we see here. Okay, so suits is our primary product. Okay, and these are given numbers. Okay, so we have unit cost is $320. Now we have one single point here. You have a current price and what is the current demand. So you have a current price of $350. So let's make that into a currency, and this also into currency, and at that price our demand is 300. Okay, now we need at least 2 points to be able to generate the parameters for the demand function, but here instead of the second point we are given that the elasticity is minus 2.5. So given the elasticity, then we should be able to figure out what the constant value is going to be for the primary product. This is for the suits. So let's look at how we are going to generate the constant. Let's do this here. So demand is going to have this format, and we are assuming constant elasticity. So now we know one point, which is if the price is 350, the demand is 300. So we can substitute those values here. So at present price is 350, demand is 300. These are given. So insert 300 for D, B sub 0 we don't know, 350 for P, and B sub 1 is given as minus 2.5. So now we have only one unknown. So now we should be able to solve this. So B sub 0 is 300 divided by 350 to the power of minus 2.5. So you solve that. So we can convert this into cell addresses. So 300 is B5 and 350 is B4 to the power of the minus 2.5, which is in B10. So let's give names here. So we have current demand divided by, okay, see this whole thing, 350 to the power of the elasticity. So that will give us the constant. Okay. Now price is what we want to find. That's our changing cell. So the demand will be constant times price. So let's give a name. Okay, let's give all of these names. So demand will be constant times price to the power of elasticity, and once again you just put some price here, so you will not have a divide by zero error. So profit from suits then is price divided by unit cost. That's profit per unit times the demand. So that will give us the profit from suits. Now we have to figure out profit from the accessories, the shirts and ties. And here we are given that complementary products, what the demand will be like. So on the average, the problem states that this is given. On the average, for each suit we sell, we will sell 1.5 ties and 2 shirts on the average. And the profit per unit for ties and shirts are given here. So we can then say profit or accessory profit per suit sold, for one suit sold. Okay. And that will be the sum product of how many units we'll sell and what is the profit that we make. Okay. So let's give a name here. So this is the profit for one suit coming from the complementary product. So profit from complementary product would be, okay, we start from demand of suits. So for each unit of demand of suit, that's the amount of profit that we'll generate from accessories. Now we're going to multiply this with this sensitivity factor. And the reason for that is we're going to run a solver table where we will change the number of ties and shirts we will sell per suit. Okay, what if it is a little bit more than 1.5 and 2 or a little bit less than 1.5 and 2, and we will increase or decrease both ties and the shirts in the same proportion. So right now it is just 1. Factor is 1, which is 1.5 and 2. Okay. So total profit then is profit from suits only and then profit from shirts and ties. So that will give us the profit, total profit. Now total profit, okay, let's run solver. So we want to maximize total profit and price. So here we will go ahead and add the constraint that the suit must be sold at least at cost, no less than at cost. Okay. Go to options, GRG nonlinear, we'll uncheck this and use multi-start. Click OK and solve. Now we have the best price for the suit at which we will sell on the average 198.9 suits, and we will also generate for each of them that much of profit from shirts. So suit profit will be 18,402 and shirts and ties profit will be 14,000. So now before we run solver, let's see what happens if the price changes, and then see what the total profit curve will look like. So we'll do a data table. So we'll go from $300 for price to $480. Okay, and we want to do a data table of the profit. Okay, profit should be color coded. Okay, so now do a table, so highlight. Okay, and then do data table. It's prices in column, so change to column. Okay, and press F9. Now let's plot these profits. Change the format for x-axis, going from 300 to the maximum. 480. Let's change the number format also. Currency, no decimal places, and titles. Total profit for suit and complementary products. Okay. And x-axis is price per suit, and vertical axis is total profit. Okay. Next we will run solver table. Now what we're going to do now for solver table is we will use the sensitivity factor. See, remember we multiplied by 1 for the profit from shirts and ties, and that's what we're going to change from minimum to a maximum value. So we'll go from 0 to 2 in increments of 0.2. So 0 would mean absolutely no complementary sales at all, and then 2 would be 2 times the suit sales. Okay, and the output we can, let's do the 3 of the 3 profits, and here they are. So this is a strange situation where you get when the multiplying factor is 1.8 or 2, you make no profit at all from suits. You make all your profit from the secondary or complementary products.